Now let's start to solve fractional equations. Sometimes this fractional equation may look scary, but let's use a clear systematic approach that help us to solve this problem. A fractional equation contains fraction with algebraic expression in the denominator, usually with our variable x down below. They look complicated, but here's the insight. We can transform them into standard quadratic equation that we already know how to solve. Our goal is simple. We want to eliminate all the fractions by multiplying with the lowest common denominator, and then we will solve the resulting quadratic using our preferred method. Let's work through an example. 1 over 6 plus 1 over x plus 2 equal to 3/4. Step 1, we know our denominator are x plus 2, and 4. So the lowest common denominator is 4x multiplied by x plus 2. We multiply every term by 4x, open bracket, x plus 2, close bracket. And we will have 4 multiplied by x plus 2 plus 4x equal to 3x multiplied by x plus 2. Now we can expand and simplify. 4x plus 2 becomes 4x plus 8. So we have 4x plus 8 plus 4x equal to 3x multiplied by x plus 2. We will get 8x plus 8 equal to 3x squared plus 6x. Rearranging to standard form, we have 0 equal to 3x squared plus 6x minus 8x minus 8, which gives us 3x squared minus 2x minus 8 equal to 0. If you calculate this using the quadratic formula, you will get x equal to minus 4 over 3 or x equal to 2. Note there's an additional step we need to do here. We need to check that our solution do not make any of the original denominator 0. In this case, we cannot have x equal to 0 and we cannot have x equal to minus 2. Since the solution just now do not equal to this value, we can keep all the valid solutions. Now let's walk through a more complicated example, and this will show us why checking for excluded value is important. Here we solve x over x plus 5 minus 2 over x minus 9 will give us minus 11x plus 15 over x minus 9 multiplied by x plus 5. We first multiply every term by the lowest common denominator. We can see that the denominators are x plus 5, x minus 9, and x minus 9 multiplied by x plus 5. So the LCD is x plus 5 multiplied by x minus 9. After multiplying through, we get x multiplied by x minus 9 minus 2 multiplied by x plus 5 equal to minus 11x plus 15. The expansion will lead us to x squared minus 9x minus 2x minus 10 equal to minus 11x plus 15. From here, we get x squared equal to 25, so we will get x equal to minus 5 or x equal to 5. Here is the interesting part. We must check if either solution will make the original denominator 0. For x equal to minus 5, the denominator x plus 5 becomes 0. So that's undefined. So x equal to minus 5 is not a valid solution. It is excluded. For x equal to 5, x plus 5 equal to 10, and x minus 9 equal to minus 4, none of this is 0, so x equal to 5 is valid. Therefore, our final answer is x equal to 5 only. This example shows why step 6 is crucial. We find two solutions, but one has to be thrown away because it makes the original equation undefined. The original equation is undefined because you cannot divide any equation by 0. Remember that just because you can solve it doesn't mean all the solutions have to work in the original equation.